Bismillahirrahmanirrahim. Nama saya Muhammad Khairi bin ID number 2018449136. Saya akan present untuk tajuk presentation load test and calculation for MBRS system for Suruhanjaya Syarikat Malaysia. So actually the slide presentation divided by 3 sections, which is data collected, calculation, and analysis and summary. So, background of the project Suruhanjaya Syarikat Malaysia is the process of in the process of enhancing their existing web application. Security section was engaged to perform a load test on the application performed to determine the system behavior under both normal and peak load condition. It's helped SSM to identify the maximum operating system capacity and application as well as any bottleneck and determine which element is causing a degradation. The load test scope was limited on SSM web application and they are less important. All the load test activities were performed in-house. All the activities within the project were undertaken during the period of November 23rd, 2018. Okay, the objective of load testing was to understand the behavior of the application under average load, including the expected number of concurrent user performing a specific number of transactions within the timing as per requirement. Therefore, the following are the objectives in analyzing this simulation load test project. To identify and calculate the inter-arrival time and service time with multiple service, to compare inter-arrival time and service time with multiple service, to analyze the inter-arrival time and service time based on scenario by applying querying theory. Okay, the system accommodates huge number of users can be detrimental to its smooth running and response time. A slow response time will greatly affect the performance speeds of the system at which system provided the services. As the result, the system may suffer to handle the multiple sessions for one particular user. The delay transaction might increase the customer impatient and leave the online system. This project will provide a robust problem-solving technique for system in order to operate smoothly in production environment and satisfying the customer. So we have the load test use case, which is MY. It is a load test for SSM production environment. There is some file to be uploaded, which is file name SSM FS MFRS. Zip file size is 1.26 megabyte and the export PDF also around 20.9 KB. The upload file is a valid sample is verified for the use case to test its working or not. And the test duration is 1 hour. The total number of users is 150 users. So we will calculate the inter-arrival time data of user accessing the server. There is 3 different server and 3 different environment, which is at PDC, SDC, and cloud. So PDC is primary data center, SDC is secondary data center, and the cloud is not covered on internal accessing, but from the outside accessing. So we will cover from 8:30 AM till 4:30 PM, which is the government actual work, and we will calculate on the numbers of users to access the server. And based on the figure, the average number of users can be calculated as below. The result is 120.5 user arrive in one interval, and mean interval arrival time is 29.875. So we can conclude that one server, which is average service time, is 2.0626 seconds, and for the multiple services using 3 different server in 3 different environment is 2.90 seconds. For both server, the average service time for all service, user role assignment, upload XBR file, and file listed accessing by 150 users for each server is 2.9 seconds. So after we get the inter-arrival time, we can get the result from the service time data of each server. When the number of users is growing, the response time start to grow proportionally. In the beginning, the response time is the elapsed time from just of each server. When the number of users is growing, the response time start to grow proportionally. In the beginning, the response time is the elapsed time from just before sending the request to just after the last response has been received. This is for user role assignment in 1 hour test time taken. So we can see from the 0, we load the 10 user until 150. The average is below 50, but after certain time, when the number of users reach 50, the total average response time maintained at under 33 seconds. The average response time increase when the number of users reach above about 60, which is 41 seconds. When the number of users reach to 120 users, the total average response time will become higher. When the number of users reach 150, it will reach as the highest average response time of 245 seconds. We can see at 40 to 120 users, the response time is still below the bar line. Also goes to user upload XML file in 1 hour load test time taken, and the number is growing proportionally in the beginning. When the number of users reach 40, the total average response time maintained at under 67 seconds. The average time increased more than par when the number of users reached about 130, which is 343 seconds. The total average response time will become higher. When the number of users reach 150 users, which has the highest average response time of 442 seconds, we can see that at 40 to 120 users, the response time is still below the bar line. And then the next test is a user browse filing history. Still the same. When the number of users is growing, the response time still spike in the beginning. When the number of users reach 60, the total average time maintained at under 50 seconds. The average response time increased when the number of users reached about 70, which is 47.51 seconds. When the number of users reach 130, the total average response time will become higher. So after that 130 user, the response become higher because it shows that the server response become slower and the response time will be increased. So that's all for my presentation, and my members, Muhammad Faizal and Encik Ahmad, will present the.
Assalamualaikum, my name is Ahmad Faizal Muhammad. I am a second presenter. So my ID number is 2018833634. So for this session number 2, I will explain about the calculation by using the MM1 and MM3. So before we proceed, so for the data calculation for the MM1, we will start from the calculation on the arrival and the service rate, and second, to find the arrival and service rate for multiple server with each services, as previous explanation by Khairi. So our situation is we take the example, we do a simulation between two different cases, which is using a single server and using the multiple server. The numbers of server we are using is 3 servers. So number 3, we calculate the average number in queue for the single server with multiple services. Number 4, the calculation number in queue for multiple server to find each server has multiple services. Number 5 is average time in queue and system for the single server with multiple services. And last but not least, average time in queue and system multiple server with each server has multiple services. Okay, this is actually the formula to find the arrival rate and also the service rate. When you see on the slides, the lambda is represent the arrival rate and the mean symbol is represent the service rate. To find the arrival rate, 1 is divided by mean into arrival rate, and to find the mean, which is a service rate, the 1 is divided by average service time. Okay, this is the calculation, the arrival rate and service rate. This figure we get from the total numbers of the time, which is 39.875 is actually the mean inter-arrival. So we can calculate here to find the arrival rate, 1 divided by 39.875. So the result we get is 0.0334. Second, for the calculation on the service rate, we get mean is 2.0626, which is mean divided by 1 divided by 2.0626, and the result is 0.4848. So from this calculation, for the result for MM1, the arrival rate is 0.0334 and the service rate is 0.4848. Then we go to the to calculate the arrival and service rate for the multiple server, which is each server with different services. So before that, for this case, to find the mean inter-arrival, the calculation as per following. You can see from here. In our case, we have a 3 server, so mean inter-arrival multiplied by 3, and we get this answer 89.625. So on the calculation on the arrival rate, based on the arrival rate multiple server, each server with different services, we can calculate 1 divided by 89.625. This is from here, and the result is 0.011. So the arrival rate for multiple server is 0.011. Okay, next we will calculate the arrival and service rate for the multiple server, and each server they has different services. Okay, when refer to the our case, we have 3 different service which we take as our services. First service is the user role assignment. Second is user to upload the XBRL file, and number 3 is user to browse filing history. So these are the calculation that involved in the to calculate the arrival and services rate on the server, for each server with a different services. So you can see this is the calculation for this service rate. For this is a calculation on service rate for user role assignment, which is the result we get is 0.1079. So for the second, we calculate the service rate for the upload XBRL file. So the answer we get, the result we get is 0.0523, and 93 correct services. So calculate service rate for user to browse file history. So this is the result we get. So the result we get is 0.1051. So here the result service rate for user role assignment is 0.1079. Service rate for user upload XBRL file is 0.0533, and service rate for user to browse the hiding history is 0.151. Okay, this is actually the formula of the calculating the average number in queue for the single server with multiple services. So the average number in queue for single server with multiple services, you can see here the MM1 average number in queue. Here we get the answer. So the average number in queue at queue is 0.503, which is the duration is lambda power of 2 mean multiplied by mean minus lambda. So here are the answer. So for the MM1 system utilization, the formula is here lambda divided by mean. So the lambda data is 0.0334 and the mean value is 0.4848 where we get from the previous data, and the result is a 0.06889. And one average number in the system, you can see here the system utilization divided by 1 minus P is a single, which is equal to 0.06889 divided by 1 minus 0.0689. So this is the result. Okay, for the next, we will calculate the average number in queue for the multiple server, which is for each server there has multiple services. So first, we are using user role assignment services to calculate the average number in queue for multiple server, the average number in queue and system for the multiple server. So first, we find the average number in queue first at queue. So this is the result that we get. And second, we find the utilization, system utilization. So this is result we get 0.10287. So the system utilization is 0.10287. Then we find the average number in the system, which is L in Q2 equal to P divided by 1 minus P equal to 0.10287 divided by 1 minus 0.10287. So the value is here. So means that the average number in Q for the user role assignment is 0.01. Okay, now we calculate the average time in queue and system for the single with multiple services. So this is the formula to find the average time in queue and to find the average time in the system, which is the formula for the average time in queue. You can see here is WQ equal to lambda divided by mean multiplied mean minus lambda. And here, average time in, to find the average time in the system, which is W is the average time in the system, equal to 1 divided by mean multiplied 1 minus the system transition. So P as a option symbol. Okay, this is the average time queue and system. The calculation average time in queue and system for the single server with the multiple services. So as you can see here, the calculation on the average time in queue. Here you can see this is the data that we get for this. The answer is 0.1562, and the calculation on average time in the system, you get the answer is 2.21531. So the average time in queue for single server with multiple services is 0.15262, and the result, the value on the average time in the system is 2.21531. Okay, this is next is the to calculate the average time in queue and system for the multiple server and multiple services. So first we take for the user role segment services. This is the calculation of the data that we get proposed, which is the calculation of average time in queue and calculation average time in the system for the user role segment. Second, we calculate the services of user uploading the XBRL file. This is average time in queue we get, and this is the average time in system, the value that we get. So the average time in the queue for the single server with multiple services is 4.93495, and the average time in the system is 23.69652. This is the services user browsing the file history. This is the calculation, and this is the data that we get 1.12355, and the average time in the system we get is 10.63025. So the average time in queue for the single server with multiple services for the user browse file history is 1.12355, and the average time in system for single server with multiple services is 10.63025 for the user browse file history. So these two values is represent the average time for the user. Okay, here is the calculation by using the MM3. So that we will calculate the arrival and service rate for multiple server with multiple services for the MM3. We find the average number in queue and system for the multiple server with multiple services. Then last, average, we will calculate an average time in queue and system for the multiple server with multiple services. Okay. This is actually the MM3 calculation to find the arrival rate and service rate for the MM3. So the calculation you can see here, 1 divided by 25.875, which is made the arrival we get from the previous data. So the value we get is 0.0334, and the arrival rate for this is 0.0334, and this is the calculation on service rate for the MM3. 1 divided by 2.090, so the result we get is 0.4784. So from the calculation, the result for the MM3 error rate is 0.0334, and service rate value we get is 0.4784. This is the calculation to find the number in queue and system using the MM3 calculation. definition. So for the multiple server with multiple services, so first we need to find the numbers, the average number in the system L. So we must find both, which is we must find the server utilization and the probability. So this 0.0232 is the server utilization that we get, and the probability we get is 0.4419. Then we find the average number in the system. So this is actually the calculation for the MN3. So when you get here, this is actually number 3. This number is represent the number of the server multiplied by 0.0232 is the formula calculation. So the average number that we get in the system is 0.0696. And then we find the number in Q, multiple services. So we get this value. So the average number in the system is 0.0696. Then we will find the LQ equation in NN3. The average number in Q must find the value of the time. The WQ equation is stated in the average time calculation. So this is the equation to find the LQ, the average number in Q, which is LQ equal to 0.0334 multiplied by 2.5215 equal to 0.0842. So the average number in Q that we get is the value 0.0842. Next, we find the average number, average time in queue and system for the multiple server with multiple services. So this is the calculation. The average time in queue, which is to find the average time in queue. We will minus and divide by 2.08383 minus 0.0334 divided by 0.4784. We get this value 2.01401. So the average time in queue for multiple server with multiple services is 2.01401. And for the average time in the system for MM3, we get this value 0.0696 divided by 0.0234. So we get this value as the average time in the system for the multiple server with multiple. Thank you, and that's all from me to explain about the calculation that using MM1 and MM3 calculation. So for the next section, my colleague Ahmad Musyawir will brief and explain about the analysis and summary for this project assignment. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. So first of all, I am sorry because I know that I'm late sending the videos. It's supposed to be that my group team should be sending a video yesterday, but since there is some constraint and some problem that we're having, so it's a bit we are delaying the sending the videos. So without wasting the time, so my name is Ahmad Musyawir. I'm one of the member group team with Khairi and Faizal. So I'm cover the parts of the analysis of AM1 and AM3. So basically, there is a comparison of the single server and the multiple server. As you can see on the videos, that there is a table that shows some characteristic when we are doing some testing in the server. So there is average service rate utilization, average number in the system, average number in the queue, which is LQ, average time in the system W, and the last one is the average time in the queue, WQ. So in the next column, which is at the second and the third column, there is M1 and M3. So let's compare the two of this model. So the M1 has reached arrival rate as a 0.0334, while the M3 arrival rate, its arrival rate is a 0. It is same as 0.0334. So the different thing is when it's come to the service rate, which is a service rate is calculated from the input, which is the input source, like a packet or customer, it reach to the input point until it stop at the waiting line for it's waiting to get a signal or to wait their turn for being processed into the server. So their service rate for the M1 is a 0.4848, while for M3 is a 0.4784. So by this, looking at the result, then we know that the M3 is more quite low service rate, which is the M3 has what we call has take the low compared to the M1. So we go to the utilization, where the utilization we can get from the arrival rates divided by the service rate or over to the service rate. So for M1 utilization is a 0.0689, while for M3 is utilization it takes 0.0232. So from the utilization itself, that we know that M3 for the model M3 is quite good, where the time taken to utilize the process, or when the input came to the server for being processed, it is what we call low, or it fast lah, because since this 0.0232 is quite less time to the M1 itself, which is the utilization for M1 is 0.0689. So when the utilization for the M3 is quite low, so it will affect to the other characteristic, which is the average number in the system, the average number in the queue, average time in the system, and the average time in the queue. As we can see at the table, so the average number in the system, which is L, the M1 has recorded as 1.0296, while for M3 is a 0.0696. This means that the average number for M1 is 1, while for M3 is 0. So there is when M3 is recorded as a 0.0696, as we know that average number we cannot get the decimal point, which is we need to what we call summarize into the whole number, which is for M3 is a 0. So there is no packet or customer that being waiting, or there is no other packet. There is no packet waiting in the system. So for the M1 there is 1. So same like to the average number in the queue, which is the queue has state that there is a 0.5073, while for the M3 is 0.0842. So I want to clarify something that since this PubGov project has taken just 1 day instead of the 1 week to get a more real or the actual data, so the average number in the queue is a 0 because there is a logic because the L also 1, so the average number Q and in the waiting should be 0, since what I have mentioned here that the project has been carried on in 1 day. So if let's say like if we have some more time, or we are given a much longer time, that inshallah that we can get to the data. So same goes to the average time in the system, which is for the one is we noted that 2.1253 millisecond that has been recorded for AM1, while for AM3 is a 2.08383. That we can know that we can see instantly that the AM3 is quite good. So same for the average time in the queue, which is the AM1 has that 2.1526, while for AM3 is 2.04401. So for the next slide is the comparison of single service for a server for multiple service of a server. So this table has shown that there is a 4 column. That's the first column is a multiple service for single service. It's a multiple service. So the user roller assignment uploads XBRL files and file history is the single service. So let's look at so for the user role assignment, the arrival rates is noted that as a 0.0111, but when we look at the others two, is it takes the same arrival rates, which is for the upload XBRL file and file history. It's mentioned that there is the same arrival rate as a user roles assignment, which is a 0.0111. So for the service rate for the other three single service, that there is different, which is for user assignment service rate is a 0.1079. For the upload itself, there is a 0.0523, and the field history 0.1051. So this kind of each single service has their type of their own behavior. So that's it's normal that the service rate has a different we will have a different service rate, since there is a different kind of behavior. So for the utilization, like mentioned just now, that 0.0 and the arrival rates will over with the service rate. So for the user role assignment, for the utilization, that there is so the user assignment is a 0.102287. For the upload XBRL file is a 0.20825. For the filling history is 0.10561. So so as we can see also that the left, which is the multiple service, for the calculation is we can get from the at all each single service, which is a user role assignment plus with the upload XBRL file and fill and history. So for each arrival rates for each single service, when we add all the arrival rates, we can get the multiple service, which is their each arrival rate is a 0.0334. So the average number in the system, the average number in the queue is normal calculation. What the important thing is when we are doing this project is we need to, there is two ways to do it, is either by a simulation when we we assume the service rate and the arrival rates, then the calculation for the utilization, average number in system or in the queue, or even the average time in the system or average time in the queue, we can calculate by the assumption that we done for the arrival rate and service rate. But the other things that need to do this project is by the real, we are getting the result out the data by implement in the real environment. But for this project we are implement the real environment. So in the screen that this is show that the user upload XBRL file in the 1 hour for 1 hour load test time taken. So as you can see that when time request user, the time taken to the user upload the XBRL file is 0. So that's mean that no. But as you can see, let's follow the graph. As you can see that there is an exponential graph, which is from 10 until the 150. The time taken is increasing exponentially. So until it's get to the 200 users, the users request to upload the XBRL file. So it's mentioned that the time taken is 0, which means there is some failure or timeout has been occurred in the system. So let's look at the advantage and the limitation for this project is basically IM1 and IM3, which is IM3 is a family for the IMC, which is this model is quite good, which is there can be a strategies for the testing network performance, such as the efficiency of server, or for the load testing, load server test. So in this project, it is suitable to test server load. So based on this project, the average, which is lambda, the server utilization and then the average number in the system and queue in the network are being processed and served to the pass through over the network before reach the servers, which means that the lowest waiting time or queue or delay will serve the better network performance. So the limitation for this project is like I mentioned earlier, that we are having a constraint in terms of time and server limitation itself, that when it's come to the more sample size, the output should be actual result, either good or pass, even it was a good simulation. That means that it's come to the more simple size. When we talk about the more simple size, that let's see if we're having extra time to do, so there is a probability that the more sample size can be recorded or taken or investigated, right? So even though the inter-arrival time and the service time is achieved in a day, but instead of the 1 week, that makes the results not to be accurate. So the last one is the recommendation and the conclusion, which is a recommendation for this project is optimize the performance, the characteristic. The second one is scale the environment, and the third one is to manage bottleneck. So this project is basically to or can ensure that or to clarify that the performance of network, either it's optimized or either it's a non-optimized. So it's also when we are when we are going to scale the environments of in terms of network platform, that we can use this kind of model, which is M1M3, in terms of we are calculating the service time rates and the error rates, so that we can know that the average time of queue, the average number in the queue. So lastly, it's also ensure that we can manage the bottleneck also. So the conclusion that I can conclude for this project is, in terms of the server utilization of the systems, the AM1s are more utilized than the AM3. Like the first table in the first slide, it's mentioned that the time taken for utilize for AM1 is quite greater in terms of time taken compared to the AM3. So for the average number in the system in the queue, AM1 system is more user in the system compared to the AM3. Yes, it also has been discussed in the first slide, where for the average number system, the system L, in the AM1 we have having one customer or packet or process, while for AM3 there is no. So it's quite good for AM3. So I can summarize that the AM3 system is better compared to the AM1. So that's all for my presentation. I hope at least it will enlighten you to this project. So madam, I hope that I know that from my previous project itself, that I do for the title IM3, but my calculation that I'm realized I'm using for the IM1 calculation. So I hope that you can consider my result. I hope that I want to pass this subject. So